This video is just to remind you what we studied last Friday about the cardinality of sets, because we'll continue tomorrow. Cardinality. What does it mean? Well, the cardinality of a set is just, if the set is finite, is just the number of elements in the set. For example, if I let A be the set that contains, 3 words, dog, cat, and book. Just any set has 3 things in it. I could say that the cardinality of A, I'll just write card A, is equal to 3. Or if B is the set of even numbers, 2, 4, 6, 8, up to and including 100, we would say that the cardinality of B is the number of elements in the set. Well, 1 through 100 would be 100 numbers, but this set has half of them in there, right? Just the evens. So the cardinality of B is 50. Now you might ask, why do you use that new word when you can just say the number of elements in the set? Well, the reason that we create a new word is because when we talk about infinite sets, what would you say other than infinite if I ask you how many elements are in the set? Students say, well, infinite means infinite. And what we learn here in Chapter 3 is that there are different cardinalities of infinite sets. They're not all the same. So you might ask, well, how do we compare infinite sets? And the answer is we compare all infinite sets, at least in MAT 103, to the first infinite set that we ever met, the set of natural numbers, the counting numbers. The set containing 1, 2, 3, ... meaning and so on, forever. That's the first infinite set that you ever heard of. And so we're going to compare other infinite sets to it. The cardinality of the set of natural numbers also has a name. It's not in our textbook, but its name is Aleph Naught. And it's written like this character. And you read it, Aleph. Now, I'm not sure if it's N-O-U-G-H-T or N-O-T. I found it both ways online, but we'll just say Aleph Naught. That is the cardinality of the natural numbers. So, how do we know if a set has the same cardinality? Well, we know exactly the way babies knew when they're 18 months old. If the number of plates on the table is the same as the number of people in the family. They know if there's an extra plate because they make a correspondence in their mind, plate to person. So we want to compare infinite sets by making correspondences between the elements of those sets. And we will say that a set A has the same cardinality as n, our natural numbers, the cardinality Aleph Naught, if the elements of A can be paired 1-to-1 with the natural numbers. For example, if we call, let's say E, the set of even numbers, 2, 4, 6, 8, and so on, all of the positive even numbers, we could say that E has the same cardinality as n. Now, I could prove this by saying, well, I can take 2, 4, 6, 8, and so on. And I can pair them with 1, 2, 3, 4, and so on. Pairing my natural number with, well, let's see, 8 is 2 times 4, with 2n. So this correspondence here, n matching with 2n, is a one-to-one correspondence. A one-to-one correspondence. And we can conclude that E and N have the same cardinality. The cardinality of E is equal to the cardinality of N because we can pair them. Now, you do not always need, in fact, you really never need to find a formula for the correspondence, because notice what I did with E. I just simply listed the elements. There's a first one, a second one, a third one, a fourth one. And so the one-to-one correspondence comes from the fact that we can make a list. I put a first, a second, a third, a fourth. So in other words, the 100th on the list corresponds to 100 in the natural numbers. If you can list an infinite set, let's write this down. If we can list the elements, of an infinite set, the very fact that we can list it sets up a one-to-one correspondence. If we can list the elements of an infinite set, then here's the correspondence. Nth on list corresponds to the natural number n in the natural numbers. This here is the key that we will use throughout Chapter 3 to see if a set has the same cardinality as n, aleph naught. If we can list the set, if we can think of a method by which we can make a first, a second, a third, a fourth, then we have set up this one-to-one correspondence with the natural numbers. If we cannot list it, if it's impossible, if it's too big to list, then we will know that we have a set that is larger than the natural numbers. But as of Friday, we didn't even quite get this far. One thing we did discuss that I'd like to mention in the video is on Friday we showed something very strange about infinite sets. So let's say I'll put Friday's class. We noticed something different, that we can take out elements from infinite sets and not make them smaller. That is so strange. But what do I mean by smaller? I mean the cardinality remains the same. The cardinality of the remaining set does not always decrease. Of course it does in a finite set. If you have a set of 25 things and you take out 3, the cardinality becomes 22. That's just our natural logic. We know that. But in infinite sets, that's not necessarily true. And the handout that I gave you gave some examples. Let me just give one or two. Well, the one we looked at above, if we remove the odd numbers from the natural numbers, E, the set of even numbers, 2, 4, 6, remain? Well, we showed that E has the same cardinality as N. But the cardinality of E, because we could list it, is equal to the cardinality of N. So we actually can remove infinitely many things from the set of natural numbers and not change the cardinality. We can also remove infinitely many things and change the cardinality. Here's an example. If we remove all natural numbers greater than 100, well, then we are left with this set. 1, 2, 3, up to and including 100. Let's call it R for remaining set. Okay, well here the cardinality of R is simply 100. There's 100 things in there. It's finite. And of course that is less than the cardinality of N, which is Aleph naught. So that's about where we were. The question that we're going to ask ourselves tomorrow is, can we put more things into the set of natural numbers and not increase its cardinality? And if so, is there a set that has a larger cardinality than N? If not, then we can just say infinity is infinity. But that's the question that we're going to do in sections 1 through 3.